Programming Throwdown, episode 169. HyperLogLog. Take it away, Jason.
Hey everybody. So Patrick, do you have are all your cars electric? Any of your cars electric? Do you have an ICE car?
Actually, I have one normal car and one, the plug-in hybrid we discussed. So it does have a battery, but it also has a regular 12-volt car battery.
Oh yeah, that's what I was going to ask you. So even the hybrids have regular car batteries.
Well, the hybrids for sure. I think even electric cars still often have like 12-volt sort of normal car batteries for a variety of purposes. But I don't know, to be honest,
Oh, okay.
if a Tesla does.
I mean, it's probably better than trying to like convert, from whatever voltage the engine battery uses.
It looks like here they do. Just a quick Google says that, yeah, they have the normal lead acid 12-volt batteries.
So, how do you know when your car battery is dead? Do you just drive until the battery stops working, or what do you do?
I mean, in an overall thing, I guess, yeah, the car can't start. So I don't know how that works in electric. Your accessory systems, like when you sit in a car before you start it, it probably doesn't turn on.
Yeah, so like in my experience, until recently, I have never tested my car battery. And so basically what will happen is I will just drive until the car won't start. And then I will have to go and desperately figure out how to replace the car battery, and it ends up being this big thing. And it's just gotten worse as like we've gotten busier over the years. So it culminated when we were about to all go camping and the car didn't start. And we've had the same battery for a while, but part of it is, you know, you never totally know without a tester if it's the battery, or if you left the lights on, or if there was some kind of glitch that caused the energy to drain. Like we had the key in the car, like not literally in the ignition, but we had the key next to the car. And I feel like just having the key so close to the car, it somehow got confused and it
Oh,
thought we were in there or something. Um, because I'm actually, so I guess to end the story, I'm ordering a car battery tester, which is only $20. I thought it was going to be like hundreds of dollars, because when they anytime they do anything at the dealership or you call someone to do something, it always seems like, oh, like this must be some amazing device that must be manufactured in a laboratory in the middle of the earth or something. And so no, it's like you can get a car battery tester for like $20.
do you have to disconnect the battery? Not remove it, but at least like disconnect the terminals, like the rest of the electrical system for it to work? Because that's an annoying thing if you do.
Yeah, I don't think so, right? Because as long as the car is not on, it's not drawing any amps. So it should be an insignificant draw. So we're gonna find out. I'm gonna get the car battery tester on Tuesday, tomorrow, and I'm gonna see what the instructions say. And yeah, I'll let you know. But I'm pretty sure, just putting my engineering hat on, that as long as the car is not on, and well, the car has to not be on, and not even on accessory mode. Like the keys have to be far away and everything.
I could see that. But it's not a voltage thing, right? So the thing you're describing is, can you pull enough amps temporarily to turn the car over, right? So it's like measuring like rush current that it can deliver.
Yeah, so this $20 thing, what it needs to do is draw enough amps for a certain amount of time and make sure the
Mhm.
voltage doesn't drop, right? I think that's, but it can also tell you, it can actually tell you whether the battery, like all the cells are just old, or if you have one bad cell. I don't know what you would do with that information, but it can tell the difference.
There's probably a voltage based thing, knowing that all the batteries are made from the same chemicals or whatever. So
Yeah, that's right. Yeah, I think if you have one dead cell, then you'd consistently pull a certain number of amps, but at a lower voltage,
well, you'd
right?
have
Because they're all
one cell's
serial.
voltage drop missing. So you like, if, I don't know how many cells are in a 12, but like you would go to 9.3, and that's like all your cells are good except for one.
Yeah.
Versus if you just had like 10 instead of 12, then okay. So that your mission, should you choose to accept it, is to crack open the tester, to look at the circuitry and figure out what it's doing. Figure out what it's doing.
Yeah, after the last episode where I burnt the Raspberry Pi, and I literally have an imprint on my finger from the SD card, I don't know if I'm gonna crack open the battery voltage tester, but um, but yeah, I guess I'd be interested to hear what people out there do. So if you just drive your car until it doesn't turn on. If you have some regiment that works for you and you've never had this happen to you, either end of the spectrum, let us know. Um, I just, it kind of like it didn't ruin our camping trip, but it definitely set the camping trip back by like multiple hours. So I kind of feel like I need to improve this area of my life. So we'll see how it goes. If you have a way of doing this, let us know. Actually,
All
Patrick,
right.
do you do anything or do you just drive the
Nope.
car until it doesn't turn on?
Yes, that one. Which is horrible. I think when I take it for its regular oil change, I think one of the things in the checkpoint is they hook up their expensive battery tester to it and then try to convince me to buy their battery. So that's been I do regularly get the oil changes on schedule. Um, I don't know if that actually is super critical, but I for whatever reason I just choose to do it that way. And so
Yeah,
I
I mean,
hope is
I
that
do the
that would
same
catch it.
thing. I get the oil changes on schedule, but I've never, as far as I know, I've never had a mechanic tell me I need to change the battery. It's always just died.
Mm.
So, oh man. All
All
right,
right,
on to news.
you're first up.
All right. So, we never really talked about this. This is a news article about, Google continuing to do layoffs. But, the particular article isn't what I want to talk about. I want to talk about tech layoffs in general. Um, my view of it, there are layoffs. There have been layoffs for probably 18 months now. It kind of oscillates. So there's layoffs, and all of a sudden, there's even articles about companies laying people off and then desperately asking them to come back. It's a very volatile situation. Um, my overall take on this is that I think that it's a really complicated situation because on one hand I do think people should choose degrees and majors and careers that have a addressable market, right? So if you get a degree, well, depending on what your goal is, but if your goal is to enter industry and you get a degree in American history, that's going to be really difficult. I mean, there are, you don't need to do what your degree is, um, but it's just making things a little bit more difficult. And so someone might say, well, with these all these tech layoffs, maybe we shouldn't get a major in engineering or computer science. Um, I think my overall take of this is engineering is still an extremely strong discipline career wise, relative to the spectrum of degrees or things you could study. And so I wouldn't be really phased by this. If you're a high school student, college student, I would choose engineering if it's something you're interested in and not really be worried about layoffs. I wouldn't make that a really big factor in which college major you're going to pick. What do you think, Patrick?
Yeah, I agree. I mean, I would love to say that the if you look back to other periods in time like 2001 or other the great financial crisis and that the layoffs were completely merit based. But I mean, I think the unfortunate truth is when a company goes to lay off, when a company hires, people hire against different reasons, different performance targets. They might be over specializing, over generalizing, hiring less quality than they need, overpaying for whatever. There's just so many variables that go in. And I think when a company goes to do layoffs, it becomes very difficult to sort of like run some strict merit based thing because also layoffs normally come from top down, right? Normally the bottom people aren't doing the layoffs. So it's the top down that, hey, there's a target to hit. And but bottom up, there's this like obfuscation that happens where everyone says their team is overperforming because it's sort of a game theory thing, right? Like you don't want to say, oh, I have a team full of underperformers. And that's why that sounds bad on the manager, right? So you get this like information problem. And so I think when the layoffs happen, it unfortunately it isn't always very fair. But to Jason's point, I do agree that on a whole, I think the industry is fairly robust, and there are other people hiring. But times are exuberant and times are lean, and I think what often can happen is if you are in the wrong part of the hype cycle when you come out of college, you can have sort of wrong expectations like, oh, I'm going to start out and make X dollars, per year. And then if times get lean and you're sort of waiting for a better offer, that matches what you heard. It's like, well, unfortunately, the situation is dynamic, and like, it's not necessarily true that those offers are still there. And so you got to kind of, be aware of that. But on the whole, I think, as an industry, there's still growth here. I mean, people kind of say, which they've always said, oh, AI, offshoring, whatever. There's always some threat to computer science or engineering, disciplines. But I'm not over worried about it myself, and I would still encourage people who are interested in it to pursue it. I think there's lots of adjacent jobs you can do if if things got really really lean. There's plenty of other things you could apply the skills you learn in getting an engineering degree to. And so also though, I will like give a shout out for the finance stuff we talk about sometimes, which is the importance of having savings and not living paycheck to paycheck. And it can be hard when you live somewhere expensive, but making sure that if that does happen, where you have to sort of go a few months before you can land another job, and have the freedom to not have to just take the first thing that comes across your sort of desk, then I think that's a huge benefit, and gives you a little bit more confidence to kind of seek out the thing you're looking for. But yeah, I agree. I'm not overly concerned about it. I think like this latest round that you're mentioning are a lot smaller, so the news likes to hype it up because everything's dramatic. But there have been serious cuts. I think the cuts are tapering off. We're probably seeing the last of them, but you'll always see companies wind down, but new companies start up, and it's kind of an ebb and flow. And so as a whole, I think the health of the industry in terms of compensation and stuff is probably steady, probably not as exuberant as it was 2-3 years ago, but holding steady.
Yeah, I agree with that. Yeah, I think you brought up a really good point, which is, you know, and I know we've talked about this before, but when you start out, let's say you're in college right now, you're looking for different careers. Your goal should be to learn as much as possible. And in fact, like most companies will have source control, will have peer reviews, will have like a lot of different disciplines that will be really important for you to pick up early. And so you really can't, as far as I know, you really can't go wrong. I mean, obviously, I've only had one first job as one human being, but you really can't go wrong with your first job. You can always find stuff to learn. There's just a huge expanse of things that you need to know to be a professional developer, and you will learn, at least 70-80% of that almost anywhere. I would say that maybe the place that's the most risky would be to join something extremely early. I heard a hilarious story. I don't think I've ever talked about this on a show where this was back when Java was really popular. I had a buddy who worked at a really small company. It's only just a handful of engineers. Most of them were straight out of college, so there wasn't really anybody who was experienced. And Java used to have these things called jar files, right? Which were
Mm-hmm.
basically zip files with some metadata that told you like which Java file to run first. And I'm probably butchering that, but that's basically what it was. Um, and so most people don't know that jar files under the hood are just zip files, but these folks did. And so their, continuous deployment strategy was to build the code on their computer, guess at like which .class files changed, like based on which Java files they changed, and copy those into the zip, into the jar that was running on the deployment, like on the production server. So there was no source control. Everyone just copied, source files to each other over like Windows shares, and so when it was your turn to like update the code, you would open up this jar file and start dropping Java class files in there. So that's a difficult situation to learn, continuous deployment and source control and all of that. So that might be something I'd be concerned about. Um, but most medium to large size companies, actually all medium to large size companies and most small size businesses would be just fine.
All right. Well, taking a hard turn there from the seriousness of that, but I agree with what you say. My next news article is my continual stream of shader descriptions, which is in my I've given up the belief that I'm going to build a killer game. So now I'm just like, I'm going to build a killer shader for, making a cool visual demo. So this is real-time dreamy cloudscapes with volumetric Raymarching. Ooh, that's a mouthful. Check this link out. This is by guessing by the name of the blog. I think it's by someone named Maxime Heckel, is what I would guess there. But I think that's right. And they have an article on their blog about doing a couple of things. First of all, rendering clouds, as the name says, in real time. So, doing it nice and fast. It's a beautiful thing if you check it out. But also interesting is if you sort of click around through the linked articles, they have a ton of really just interesting examples of doing shaders and how to kind of make them work. And so shader is code that roughly runs on your GPU and, sort of has instructions per pixel about what to render. And it's source of a lot of like, how do you call it, like computer generated art, demo scene style
Yep.
things, which we've alluded to before. But also this discussion of Raymarching has come up a few times I feel like those things ebb and flow. I think it's the algorithm just like honing in on me, but like whatever. So I've seen a lot of YouTube videos or whatever about Raymarching recently. And so it's on my like list of things to look into, which is a way of sort of thinking about raycasting and, understanding how close you are to something, sign distance functions. Anyways, tons of good quality
This
thing. It's
is
like a
so
jumping off point.
cool.
So I one day aspire to make beautiful, like mellow screensaver like shaders, like these articles I keep touting out for everyone.
This is amazing. One PSA: don't look at this in Firefox. It will
Oh,
cause all sorts of heartburn, but on Chrome it works just fine.
okay.
Do you do this, Patrick? I use different browsers on my work computer for personal and for work things. That way, it's like the most isolated environments I could think of.
Oh, yeah. I do that, but it's sort of a more because it's a requirement rather than a sort of.
Okay. Um, But yeah, on Chrome it works just fine. That is so cool. I wonder how many of these things are commodities. If you were to use Godot or Unity or one of these things, do they just have volumetric ray marching, or is it too cutting edge?
Oh, that's a good question. I probably it's like you could probably find out implementations of it and pieces, but I think this is one of those things that you kind of piece together the sort of almost algorithms into building the look of your game or your demo or whatever. So you may do things like compile various ways of doing water rendering and cloud rendering if you're doing this kind of thing, and so I think you might be able to pull down certain it's not like shaders. I don't think that my understanding is not like pulling down a model, like downloading a model and like rendering the model and it's rigged and you do animations. Like those things, I think you have common utilities for. The shaders are more like the sort of look and feel, and so you can probably have a jumping off point with them, but you sort of combine them in your own way to give your game its unique style, or realistic, kind of thing. But I think a lot of
That
people
makes
at
sense.
independents are pursuing a very stylistic approach, so that it kind of looks unique to them or whatever. So rather than hyper realistic is a really tough game to play in.
Yeah, that totally makes sense. All right, my second news is I've been diving into. Okay, so what was your first computer, Patrick? First
Uh,
thing with a keyboard.
it must have been one of those. What is that, like an Apple IIe?
Okay. Yep. Yep. We had those in school. I had a
Yeah.
Commodore 64, and I also had an Apple IIe at school, and I've just been going down memory lane on old, like original games, like the first few games I ever played.
Hmm.
One of them was this game called Street Beat, where you ran around with a boombox, trying to hit people in the face with music notes to make them dance.
What?
And so the way it worked was first you had to find a song, and the songs were like in people's houses. So you'd see a glowing door. That was a sign that this person had made an awesome song. You'd go in his house, you'd take his song, and then you turn on your boombox and hit people in the face with music notes. And once you've hit a certain number, then the song was like, I guess like proven to be good or something, baked in or whatever it is. And then you would take your baked in song to your house, your own personal house, and score a point. And so I don't remember how many points you had to get, but um, anyway, so that was Street Beat. I came across one that I played with my family when I was really little that kind of blew my mind in that it was really a interesting crossover that I don't think I've seen since, called Robot Rascals. And so the way Robot Rascals worked is it was a card game and a computer game all in one. So, the cards were your private information that no one else could see, and the computer was sort of the community, information. And so you would take turns playing this game on the computer, but you would have your private information. And you try to, based on what other people were doing, try to guess at what their private information was so that you could exploit it. Um, and I just yeah, I have so many good memories of this, but I haven't really seen anything like that. There are some, companion apps. So if you're playing Monopoly, for example, there's like a companion app where you don't have to pass paper money around. There's things like that, but those are more assisted tools. I haven't really seen like a board game app kind of, crossover like this. Have you, Patrick? Have you seen anything like that?
Yeah, I mean there are a few. So I think I played like a Ticket to Ride where like everyone has their tablet and the screen is rendering the common thing, but you can also do pass and play or whatever, where like the color. Oh, I don't know how people. Anyway, the color of the cards you have, it shows at your turn. There's also I think one for Suro,
Oh
another
wait,
board
hang on.
game.
I don't know if maybe
Maybe
I
I'm
don't know
missing what
if
you're.
okay, so what I'm saying is you have physical cards. So you're playing a physical card
Oh,
game, but then the computer has like the other half of the game. So like the computer
oh,
doesn't
it's
know
like
what cards
combined,
you
like
have.
hybrid. So it's not like you're
Yeah.
playing the board game as a. Oh, okay, no, I missed this. Okay,
So like
so
you
you
could
have
you
like a
could
deck of
cheat.
cards like holding in your physical hand.
Right, right.
Oh, wait, what? And so
So
you have to enter information reliably into the computer?
so yeah, so like you could like basically like you could tell the computer like I have a right to mine this rock, and the computer has no way of knowing that because it doesn't know physically what cards
Hmm.
you have. So it just
Got it.
assumes when you say something you're right. Um, but yeah, I mean, you're also playing with other people, so they would, if you have a right to like mine this rock and someone else is just looking at that card, then he knows you don't have it. So you can't really cheat per se.
Yeah, yeah.
But yeah, like you need the, it's
Okay.
sort of like the physical and the virtual kind of in the same space.
I I think I have heard of something like that, but no, I've never played it. Where like yeah, like the engine of the game can be very complex because all the accounting is done by the computer, but you still are playing a physical game.
Right, right, exactly.
Yeah,
Yeah.
no, that's cool.
Yeah,
And
it
and
was
this
it
was like
was
an
pretty
old
wild.
game, right? So it looks
Yeah, I
like you were
mean,
saying it's like
Robot
80s or something.
Rascals, I definitely played it as a very little child. It came out 1986. So I was actually 4 when it came out. I mean, I played it. I was probably like 8 when I played it, but
Very cool. Wow, that's nice.
yeah, so folks out there, if you're in game development, this would be like a interesting area. I don't know if it's sort of like just, past its usefulness, but I feel like there might be something cool there. We'll see. Maybe someone could write in and say what some contemporary equivalent is.
Well, I mean, an alternative to what you're proposing is you could go into virtual reality and the game could just be sitting on the table in front of you. And if you wanted sort of a newly released virtual reality headset, you could use the new MetaQuest 3 headset,
Do you
which
have
is
one of these?
no, I don't. I don't.
Uh,
But I just bring it up because I feel like it's one of those, there's a couple like space travel, random finance threads, virtual reality. There's like a few things I feel like we keep weaving through our podcast over the years, and so our podcast is old enough that we've seen some of these things mature. And so interesting,
yeah,
MetaQuest 3 is like a sort of I guess it's the latest released hardware. Of course, I think there's the Vision Pro, which people are talking about coming from Apple next year. I think is what they're saying. But for the MetaQuest 3, this is out. You can buy it, and the sort of like it does a lot of things, right? Like just revs everything. But the pass through, where your cameras on the front that are sort of eye distance apart, passing through to you on the inside, so that you can do the mixed reality. This is the thing that everyone really wants to make happen, is the augmented reality, the mixed reality. And so you are seeing, which is kind of the funny thing, the what happened when Google Glass was coming out, which is like people sort of out in public using their headsets in weird places to
Hmm.
record stereo video, yes, but also to like be somewhere but also not be in that place. And so it's sort of this interesting I guess, zone between this being a real thing where you just put on glasses and see it because you're still wearing a headset. People are very aware of what you're doing. But yeah, I know I do play still I have a Quest 2. I want to call it an Oculus Quest, but they deprecated that. But to be clear, it was like on the branding of my box. So I feel like I still call it that. Anyways, the Quest 2, and I've really enjoyed it. I feel like they sort of figured some stuff out. The games, we play, we keep playing, and we've talked about that before on the show, getting exercise in the game and just
Yep.
generally how immersive it is. I've been playing I guess I could have made that my tool of the show. I didn't. Oh well. Which is I Expect You to Die #3. Which I told to someone and they looked at me very funny, like, what kind of horrible game are you playing? It's like, no, no, no. It's like a lighthearted puzzle room. So anyways, I Expect You to Die #3. I feel like, people have kind of figured out the formula a bit for some of these things that work, and it may be your cup of tea or not, but excited to continue to see stuff coming out in this area. I don't know where it's going. I don't know if this is like the next big thing or not. But definitely excited to continue to see how it shapes up. And at least, for me, being a casual person involved here, enjoying some good games and entertainment as these things mature.
Yeah, I mean, I'm one of those people too that plays the Oculus Quest 2 at least once a week, sometimes even like multiple times a week. And but something that like is kind of interesting. I play basically the same two games that
Mm,
I've had almost since the beginning, and so I don't know how much of a commercial success it is, but it creates a ton of value. Basically for me, I just play boxing and sword fighting, and originally I got it to where I was playing boxing on the harder and harder difficulty levels, but I realized two things. Number one, you know, I'm not really very like fast in terms of reaction time. And so, and number two is like when you start whipping your head around, it's just not very comfortable. So I thought, okay, I can make this more difficult by adding weight because I know boxers do this in real life, right? They have like really weighted gloves when they train and stuff. And so I got these wrist weights and I've been kind of just adding more and more weight and playing these games on the normal difficulty, just with more weight. It is amazing, like, number one, how much harder it is. Even with 1 pound of weight on each wrist,
that's a
you'll be
lot.
amazed. Yeah, you'll be amazed at like how slow you punch and how slow like you get your hands back in a guard and all of that. And I got this is kind of ridiculous, but I'm up to like 5 pounds of weight on each arm.
Uh,
So I have these they're meant for your ankle, but I put them around my wrist, and I have another one that has a thumb loop. And so I have these like basically two weights on each arm, and I'm doing boxing, and it is like a heck of a workout. I mean, it's just you'll be sweating bullets after you do it. It's a ton of fun.
so you're ready for a street brawl, is what I'm hearing.
Yeah, I was talking to a friend of mine who he's kind of a hobby blacksmith, and he told me that um, I always thought that swords were like 30 pounds. But no, like swords, in real life, like a broadsword or whatever is only like 6 pounds. And so, now, granted, there's even more of a cantilever effect because the sword's weight is, not even close to your body. But I'm starting to approach what it feels like to hold a real sword, and it's it's a ton of fun.
So if you get stuck in one of those time vortexes or whatever, and you end up in medieval times, you'll be ready to go. You're ready to rock.
Yeah, I think the challenge is, I'm used to moving through people, not
Oh,
used to people
oh,
actually existing in
giving.
a physical plane.
So as long as if it's a lightsaber, you're fine.
Yeah,
Uh,
as long as nobody hits me either.
every plan is good until you get punched.
Yeah,
Um,
Mike Tyson, right?
yeah. Um, so, yeah, random sidetrack. Okay. I wanted to go back to one thing you were saying, which I don't know if we talked about on the show, so I'll mention it just really quick, so that in case we've talked about it before. But when Activision was on trial, that was earlier this year, I believe, it came out that there are 1 million PlayStation users who literally only play Call of Duty, literally nothing else. They have their
Wow.
PlayStation and they only play one game. And something like there was 6 million who spend 70% or more of their time playing a Call of Duty. And so
Wow.
you're like, I only play 1 or 2 games. I'm the same. I feel bad if I just keep playing the same game, Factorio. But if you just sit there and play all your, but actually, I think, you know, this is quite normal. Is what the statistics show is people just end up really liking one game, and for very long periods of time, they just play a single game.
Yeah, that's wild. I mean, it's very hard for that industry to make money if they have to sell those units. I think they sell the units at a loss, and if someone only buys one game, it's just really difficult.
Yeah, no clue.
All right,
All
time
right.
for book of the show.
All right, so I'm going to go fast because mine's a cop out. Mine is the paper we're about to talk about today. So we're talking about an algorithm, HyperLogLog. Stay tuned. And so my book of the show, which isn't a book, it's a paper, and it's a paper by Google Research, which is where HyperLogLog was sort of written up. So check that out. If you're not a fan of reading papers, I know Jason, reads a lot of papers, but I don't. I find them very difficult. I don't prefer them. I don't like the way that they're presented. I think they're pretentious, but whatever, come at me. Uh, Anyways, all the PhD people are coming after me soon. But I find that they're not written for clarity, but written to sort of affect a certain style. This paper is no different, but there is some good stuff in here. There are good graphs, and even just I've just given up that you don't have to understand every line of a paper or even like the notation. Just
Yep.
just kind of like reading it once or twice. And if you sort of go through a couple of papers, and people will often reinterpret a previous paper, so for papers that are sort of seminal, you can kind of read a later paper and get a better description. Anyways, don't feel bad if you're not a paper reader. I would say as part of like some small percentage of your education, if you're not a sort of master student or PhD student or PhD graduate, still don't shy away from looking at papers every so often when they come up, and just sort of like reading. You can occasionally glean really interesting tidbits or insights. Not always. There's a lot of junk. Anyways, HyperLogLog paper. That was a weird rant for a book of the show, but there we go.
No, I think it was really important. I mean, we must be on the same wavelength because my book of the show is also a research paper, and
I
I,
didn't
I
know this. I
actually,
saw it in there and I thought it was an actual book.
yeah, I went into today's, our show thinking, man, I've read so many research papers, but made zero progress on my Audible books. I'm just going to talk about a research paper, and then here we are. Um, I'll go pretty quick too because I want to get to the content, but basically, NVIDIA has this really interesting thing where they're using large language models to try to fabricate goals for this reinforcement learning robot. So, for example, they'll ask ChatGPT, but I'm just starting to get into this paper, so I'm not going to do it justice right now. But they'll basically ask ChatGPT for like what are certain things that we can do to show that we kind of have good ambulation, and then they'll kind of just keep riffing on that. So I do feel like um, one thing that's always missing with reinforcement learning is you have to train from scratch versus, for example, if you're driving a car or writing something down or whatever, you're starting from this base of all this common sense reasoning. Um, so okay, here's a good example. So like, we have the AI to play Atari, right? And so, the way it works, if you want to play Pong, is you start off, just moving the paddle randomly and losing. But then sometimes you just randomly hit the ball and you get a point. And so that that creates a target, and then you start marching towards that target. Um, this becomes a really big problem in something like an RPG. So if you want to play a role-playing game with AI, you're gonna have to like try every spell randomly, move around randomly, because you're not drawing from a common sense reasoning bank. Like you don't the AI doesn't know that well forests usually have more dangerous enemies than roads because roads are generally guarded, or fire works well if the enemy looks like he's made of ice. Like these are all things that you could just do on the first try, but the AI has to like trial and error its way through. And that's why you don't see, you know, AI playing Dragon Warrior, for example, right? Because there's just too much common sense that has to be just learned from scratch. Um, and so this interested me because I feel like maybe we can somehow draw from the common sense that's been accumulated in something like ChatGPT or GPT-4. I think there's something to that. Like, imagine if you somehow just fed the visual and the textual content to some type of embedding and then trained on that, then maybe, like Fire 1 and Fire 2 would go into this embedding and you would just learn in general some things about fire, the fire spell or whatever. So I feel like there's something there, but it's very early days.
That's interesting. So rather than like combinatorially exploring the space and finding out that like if the attribute ice or whatever is attached to a enemy, then use a fire spell. I guess like you use a Pokemon maybe is a good example. Like, oh, visually this thing looks like it's frozen or, has an ice type associated with it, or I've memorized that. Like I should use a fire spell. Like you said, that's done that way, even though it's an abstract concept. It's just rock, paper, scissors, right? But that
Right.
transitive is encoded to you as a human because it maps to something you understand, which is like, if I have something made of wood, something with fire will destroy it, and wood would have a very hard time fighting something made out of fire. And so you're sort of saying you could kind of like get that understanding by combining two approaches, something that understands the context being given to the human and then the normal, sort of, yeah, interesting.
Yeah, exactly, exactly. Like, I mean, of course you could, well, I don't know if of course. I mean, you could theoretically cheat if somehow you could read the game's RAM and figure out like, okay, this character has this, ice attribute, right? But like that's not how humans do it. Like humans are just looking at the picture. And so to really play Final Fantasy or Dragon Warrior, these other games fairly, like to show it that an AI that is really representative of solving the problem, it has to be able, yeah, to just look at things and infer based off what it knows about the universe.
So I guess the equivalent would be if a computer designed a game that it thought was interesting based on the rules of the game and then presented it to you as a human, you would be like, this is not fun. This is just like some abstract concepts. But
Right.
the AI would be okay. You would be on a more equal footing. But because game designers are humans designing for humans, yeah, you got to cross that chasm before you put a computer on equal footing.
Yeah, I mean, imagine like a Poco. Actually, they have these where it's like they randomize the game. Have you heard of these game randomizers?
Yes, yes, yes.
Yeah, and so they, imagine a game randomizer for Pokemon where it just randomized all of the strengths and weaknesses of all the Pokemon. It would be just terrible because it's like, oh, the turtle that shoots water is actually, a fire, entity, and it would just be really frustrating. Like that's how the AI feels.
I, I, am I supposed to empathize and feel bad for the AI, Jason? Help me out here.
Yeah, I mean, it only makes billions of dollars, controls the stock market. I mean, you should feel bad for this thing.
All
And if
right.
you
Well,
like takes like that, you should subscribe to us on Patreon. If you're not an AI, you should subscribe to our Patreon. We really appreciate it.
if you are an AI, you can also subscribe to our Patreon and fund this very important source of training data.
That's right.
So yeah, thanks to all the Patreons. We had a lot of people stick around for a very long time, so it's always an encouragement, and thankful for the support.
Yeah, definitely.
All right, it's time for the tool of the show. Well, I'm returning to form and giving another game. This is, I mentioned Factorio earlier. This is in the style of, I guess it's closer to Satisfactory if you've played Satisfactory, which is, there was a kind of a lot of stuff sprouted up around the Minecraft culture, sort of Terraria and several others. And I think we're seeing kind of the same thing with, I don't know what you call them, I guess factory building games. I'm not sure what the
I think
official
that's
term,
right.
like base building plus factory building. And so Tectonica is a new one I've been playing on my Steam Deck, actually. Many of these games, like Satisfactory, actually don't really have very good sort of controller support. And people do play it. So someone's going to write in and be like, I use the touchpads for the 37 shortcuts that you need. And it's not something you would sit down and expect to play on your Xbox. Recently, Factorio added that, and so that was actually when I picked it up and started playing on my Steam Deck. But I've been playing this one, Tectonica, and so all these add a twist. So this one is 3D, which is adds an interesting dimension to your ability to build your factory and how to align things, because it's in a first person sort of 3D thing. And then the second thing is that you're underground. So you're in caves, and caves, of course, like limit how you can sprawl your factory even kind of more than normal. But you're also given, drilling equipment, basically. So you can carve out, paths to, extend your factory line or add stuff. And, you need plants to fuel some of your, combustible machines, like smelters. And so you need to hydroponic growing, because it's a pain to run around and gather, harvest the random
Yeah.
thing on the walls. So, anyways, Tectonica, it's still early access, so I guess in theory it's buggy. I did actually hit one bug on my computer, but in general, very playable. I've not hit like some nasty crashes or anything. And a lot of these games, interestingly, are Satisfactory. I think is in the same thing. Still technically access, early release, whatever it's called. And so it's not formally done yet, but very, very playable with beginning and end game and all of that. And so Tectonica also is nice because it has you may not like the story. It's not an RPG level story, but there's definitely like a story to it about what's going on and sort of like accomplishments to work your way through that are sort of very specific to unlock and narrative that goes along with it. So I'm enjoying it. Tectonica, I checked it out. On PC,
Very
so
cool.
mobile as far as I know. I think Xbox, PC. I don't know about PlayStation.
Oh, very cool. I'll check it out. Yeah, I love Factorio and Satisfactory, so this is right up my alley. I'm gonna give it a shot. All right, my tool of the show is the ESP32 development board. Have you heard about this, Patrick?
Yes.
You have? Okay, I'm gonna say what I think it is. I literally just got one. I have actually two of them right here. I'll hold it up for the audience to not see because we don't record video.
But actually, that
Um,
was useful because I was wondering which development board you have, so I could
I
tell
have
which
this
ones it's not.
tiny one. Yeah, it's like the size. How would you maybe the size of a stick of gum, basically.
Okay, yeah.
Um, and Yeah, and it's the thing that caught my attention was that it has Wi-Fi. So it's the Raspberry Pi Pico W. I have a couple of those. Those also have Wi-Fi. Those were significantly more expensive. This is like extremely reasonably priced. I have a link to the actual one I bought, and I bought two of these for 12.74 US. So what is it, like 620 a piece or 670 a piece? So yeah, very reasonable. And I haven't tried it yet. They're still in their vacuum seal bag, but or static bag, whatever it is. But I definitely want to give it a shot. It supports Arduino and MicroPython, which is pretty cool. So you could use either of those. Um, yeah, the Raspberry Pi and the Arduino, they only support their own thing. This one supports either. I'm generally a little leery of things that are just so open-ended that maybe it won't do any of those well. The instructions on that came with it walk you through how to set this up for Arduino, so I might just stick with that. But yeah, just the fact that I can get Wi-Fi in a small form factor is really neat. I think next year what I might do is I have a one of my Eero, Eero is a mesh Wi-Fi thing. One of my Eero, capsules is pretty close to the front of the house, and so I'm thinking I can actually have robots in the trees next year for Halloween, and they'll get this Wi-Fi packet, and when they get some Wi-Fi packet, they'll swing from the tree like some giant ghost or something. So that's my plan. Last Halloween, which was just a week ago from when we're recording this, I actually went down a step. I only did about half of it. Things have just been really crazy for me, so I didn't have a lot of time to invest in it. but I'm gonna try and make up for it next Halloween. I'm gonna bring back all the robots I didn't do this Halloween and add some more in the trees if I can.
Very cool. Yeah, so I guess like the commentary I have there is the company, I think it's Espressif, is develops a little chip that does like all the Wi-Fi and has, I believe, their ARM cores on them,
Hmm.
and so all of that to, I guess, like what Jason is saying is kind of irrelevant unless you're doing embedded programming directly. But they're very very cheap and common, and so a big community has sprung up around them. So Amazon's a good source if you want them quickly. If you are willing to wait for overseas from AliExpress, you can get the original version, or at least the original one I came into, which is ESP8266, which is a 16-bit microcontroller, I believe. Again, maybe not important depending on what you're doing if you're just sort of controlling a few servos, and also has the library associated with it. And that one's like $2, or an
Wow.
ESP for like $3. So you can search like they're kind of like all cloned, but WEMOS, WEMOS, is a very common like dev board you can kind of look up. And they have ESP8266 versions and ESP32 versions. The ESP32 is a 32-bit processor, faster. So if you're needing to do more computation, they have variations of it with you can attach a camera even and do some minimal image processing on, or use as a webcam. Of course, if you're just going to need a webcam, it's better to normally just go buy one. But then
Yeah.
you normally, you know, pulling the data down and doing processing rather than being able to handle it sort of device side itself. And they all have, we talked about that last time with the Raspberry Pi. It has the sort of headers for doing I2C or SPI, and a lot of example code. And like Jason mentioned, you can use the Arduino. I guess you call it like middleware, but basically like the libraries and the interfaces associated with that. They do need to be for like hardware stuff. They have to be ported to ESP32, so you can't run the sort of Arduino libraries directly in some cases. If they're software, it's fine, but for things like I2C handling for a specific something, you may need some variants, but it's relatively straightforward. Much easier than sort of building your own PCB and doing it from scratch. But they also support MicroPython, as Jason mentioned, and Lua as well are pretty
Oh,
commonly
wow.
seen ways to sort of control these. And the big win, like Jason mentioned, which you don't normally see in a bog standard Arduino, or at least not at this price for sure, is the ability to connect to your Wi-Fi network. And so you'll see a lot of home control devices actually use these as well. And there's a lot of firmware floating out for reflashing sort of the light bulbs like that screw into your roof will have one of these chips inside, and that's how they connect to your network so that you can control them from the app. And so
Ah,
people have kind of figured
interesting.
out that a lot of these run very, very similar chips, and so there's various from easy to hard ways of sort of flashing your own stuff onto them. And in many cases, the other cool thing is rather than having it hooked up to your computer, there often is the ability to update firmware over the air. So you can just send a new update to your bat in the tree and change its behavior without having to bring it back inside and hook up cables.
Oh, that is awesome. Yeah, I'm really excited about this. I'm gonna have to. I bought this is like probably just really like amateur to you, but I bought a crimper. I've never crimped anything before, but I wanted to like basically have this thing control the servo, but I need to have a wire come out of this thing and go into the servo, and it can't be like just a DuPont cable because of the way this thing is set up. And so I actually bought a crimper. I'm gonna try doing my first crimp at some point.
Oh, yeah. I don't do a lot of crimping. I do a lot of soldering, but
Yeah,
not too much crimping. And a correction, the 8266 was actually still 32 bits, just less powerful, less peripheral devices. So for speed,
do
right?
you have to buy like 1,000 of them if you're buying it from AliExpress, or can you still buy like 5 or 10?
You can buy like one or two, yeah,
Oh,
or
nice.
five.
Oh, even
Well,
better.
shipping has caught up. It used to be a much better arbitrage, or however you say that, but now, yeah, normally they want you to buy a few to basically amortize the cost of shipping, but it's not like hundreds.
Got it.
If you're buying a tape of them, the actual chips, you probably got to buy 500 or something. But most people are buying a dev board, so you're only buying a couple.
Makes sense. Very cool.
All right. Well, it's time to talk about HyperLogLog. So Jason has warned me that he has been willing to play foil to my explanation here. Uh, Cover more broad topics. I do have some other, specific algorithms in mind. So if this goes okay, maybe we'll do some others in the same style. But let me kind of like set up and walk it through. And Jason, ask away the questions. Represent the average person out there, or the everyone else, or even me, because
Sure.
normally I'm the one asking you these questions. So the the algorithm here arrives from a difficulty that probably most people haven't really thought about. In fact, I really hadn't thought about it until it was sort of posed, which is, how do you count the number of unique items in a set? And so if you sort of imagined the classical example here, we'll just use this one. Everyone's pretty technically oriented here. Imagine you're a website and you don't want, you see that visitor count, right? And your mom goes and visits your website, and then she just like keeps refreshing and the counter just keeps going up. Like, yeah, I'm a popular website. Most people will sort of give this number instead as, unique visitors. So, you could say, oh, okay, I'm going to, store a cookie and tell if you've been there before, or whatever, right? There's various ways. But just imagine, it's sort of being written to a log, let's say the IP address, or, a unique identifier for a user. And you want to count up how many of them there are. So, like the first blush, sort of like the naive answer is, you look through your list of all the visitors and you keep track of which ones you've seen. And then every
Yep.
time you go to the next one, you look through the list. And if you see that user, you throw it away. And then you count the size of the list at the end. And then boom. And that is correct. That actually will produce the correct answer, the so-called cardinality, the number of unique visitors that was in your set of consideration. And so you may say, well, that's pretty obvious to improve. If this was a programming interview, that would be a suitable first answer. And then your interviewer would normally, up the challenge a bit, which is, ask you, well, how efficient is that? Could you do better? And so, of course, you can do better than searching through a list for unique items. And you could use a tree, right? That would be one option. And the other option is you could use a hash map, right? So you could have a hash map of all the unique identifiers. And then every time you get a unique ID in, you hash it, or maybe it's already, randomized enough, but normally you want a really, really rigorous hash. And so you mix up all the bits, you get essentially a random number, but a repeatable one. And you go to a set of buckets and you say, is that one present or not? If it's present, you throw it away. And if it's not, you insert it. And we've talked about hash maps on the show before. If not, you can go listen to them if you don't know what they are. And so at the end, you count how many entries you have, and this will also work.
Yeah, I mean, the limit of what I, off the top of my head, would do just to scale up is have a distributed hash table where basically, you do the hash and then, it's like if the hash starts with a one, send it to computer one. If the hash starts with a two, send it to computer two. And so then you have a computer for each possible value of the first digit of the hash. And so then, now like if there's, I don't know, 56 different, characters for the first digit of the hash, then like you have 56 computers and you get 56 way parallelism. But yeah, I guess we're going to hear about way even better than
No,
that.
no, no, no. So this is great. So I had a same kind of like thought process in my head, and I think that works great for live, right? So if you wanted to sort of like what I was mentioning, these visitors are coming in, and you're sort of counting them, but it doesn't work like after the effect or sort of analytic purposes. So imagine you, like I was mentioning, you have this is a log and you want to cut it by day, by month, by people that came from Europe, by people who ended up buying something, by whatever these kind of filters. And so I already referenced this comes from a paper, and the paper internal to Google, they have a column store. And so they have a distributed system for querying the column store. And this was developed because they went and looked, and people doing analytic queries, or I forget what it said in there. I won't quote it because I'll get it wrong, but a very large number of count distinct. So you write this sort of SQL query and you say, hey, I want the distinct number of these. but they're over arbitrary input. So what you say will work, Jason, but the issue is sort of like, that's like if you only really want, a handful of them live and you're not sort of like infinitely slicing them later. So not an off approach. We'll come back in a second. I think you're heading in a good direction. But the sort of first, there's many algorithms have been done to sort of solve this, and the paper even references one. And to be clear, they even recommend this one if you're sort of not going to have very many. If you don't believe that there's a lot of unique items, this one will work. And I want to talk about this one because it references something else. And we already kind of mentioned hashing unique identifier and then trying to put it in a bucket. So this first one is linear counting. So if you hash it and you put it in a bucket, but rather than in a normal hash map, you would store the identifier. And one way is store a linked list of identifiers. So the first thing in the bucket is the head node, and then it points to the next thing, and you have a linked list, right? Until you sort of grow the hash map number of buckets. In this case, what we're going to do is actually only store a single bit and not store the actual ID. So you just insert the value, and if it goes in a bucket, you just mark that bucket as having seen something, Boolean equals true, and all the other buckets are Boolean equals false. So now what you have an issue is when you have a hash collision, you're losing some information, right? You're losing the information that there were actually, potentially it was the same item, but potentially it was two different items. And so you are getting this sort of probabilistic structure. But this is going to turn into an advantage. And the rest of this is going to talk about this. And the reason why I think this is an interesting topic for the show is my background before kind of coming across a few of these was always like, you would definitely not want a probabilistic answer. You would want an exact answer. And so it would not be acceptable to be even off by one, right? That's an off by one error. And so you
Yeah.
exactly what you have. But if you're willing to give up an exact answer, the design space widens dramatically, not only for the number of solutions you can have, but also for things like being able to tune your trade-off, because you can say, how reliable can I trade space or processing for more reliability? And an example that you see a lot recently with machine learning is approximate k nearest neighbors. So we've talked about k nearest neighbors before, I think, maybe. If not, maybe that's a good one to talk about in the
Oh, I think we
future.
have. Yeah.
Okay, good. But what if you were willing to accept an approximate answer? Then you can kind of approach it differently. So this first one that I'm mentioning is called linear counting. So you hash it, you keep track, and in some cases, when you produce this random number and you go to insert it in a bucket, you're going to collide. And like I mentioned, sometimes that's you want it. You want to throw away because it's the same ID, and every one of the same IDs will collide. But sometimes another ID could probabilistically collide. And that's the second bit of this, is using statistics to say, when you're done, don't just count the number of buckets that have an entry in them, which would be an approximation. But you can do better, which is look how many of the buckets, like the percentage full your hash map is, and use that to estimate what the likelihood is that you may have seen extra insertions that missed. And
Oh.
so this is like this like clever unlock, right? For me was we don't know how many of the same item and how many you had duplicate hashes or portions of the hashes that you used are actually different IDs. But if your hash map is only 10% full, only 10% of the buckets had values, it's pretty unlikely. Like you can just say
Right.
10 of the buckets had items, so I'm just going to guess 10. But if 90% of your buckets, you had 10 buckets and 9 of them had it, then the chance that the next thing being inserted being random, 90% chance that it's going to collide, right? And so you sort of take that into account. Now there is some balance there, right? If you had 10 buckets and 10 million unique items, you're going to get like a terrible guess, right?
Right. Right.
Because you're going to fill it up and then everything will collide and the information is lost. So you do need to have an understanding of kind of the approximate number for this example, the sort of approximate number of items that you would have. So this one's called linear counting. And when I was reading about this, the thing that comes up here, which I don't know if you've used these before, Jason, Bloom filter. Have you ever used a Bloom filter before?
I've used it. I don't remember exactly how it works.
Okay, so this is very similar to a Bloom filter. In a Bloom filter, the idea is you're trying to have what things are members of the set, and you query the Bloom filter and say, via the same mechanism, basically, you hash it, you look in the bucket, and if you normally do a couple different buckets, and you say if every one of those buckets has an item in it, then the thing I'm looking for, I'm going to do a more expensive query or check or actually go to the database. But if any of the things that should be present aren't, then I know with 100% certainty that this item is not in my set. So if I'm looking up the username Jason for Jason, and I do this operation and it comes back that one of the buckets that should have had a bit set don't, then I know Jason isn't in, he's not a user. So I don't actually have to query my backend database. And the advantage is
So
you
let me see if I understand this right. So the idea is like, I mean, which is a crude example. So there would be sort of a bit for every letter and
sure,
position
yep,
pair. And so it's like, if you don't have so Jason is JASON. If you don't have the, A at position 2 bit, or you don't have the O at position 4 bit, if you're missing any of these, then you know that the word Jason just can't be there. But if you have, J1, A2, S3, O4, and 5, then like you're still not 100% sure. You have to do some extra step, but like you're confident enough that you've eliminated so many other things that's still like a huge time save.
yes. So
Okay.
if you took each of those like J in the first position, A in the second position, and you basically hash them and then put them in the bucket. And the probability of all those things you said, right? The probability of false positive is controllable. If you say, I think I'm going to have
Right.
this many true entries, I want to use this many bits, and there's calculators online for sort of fine tuning your parameters. And if you have lots and lots and lots of buckets, you can decrease your false positives. But if you shrink it down, the really nice thing is, say, on the edge node, you can't store that you have 10 million usernames, but you could store a megabyte or whatever, and in that megabyte, you could store this bloom filter and give you a reduction of and it's only worth it if you think there's lots of users going to try to log on who don't actually have usernames in the database, or
Hmm.
whatever you're trying to do. But if they do, then you can sort of not have to go to the backend. So if you imagine for something like a spatial index, and you're trying to query for an area on your computer, like your video game, you're looking into this portion of space, and most of the portions of space are empty, and you just have entries of where there are things, then you could filter out the expensive sort of collision detection and all of the other things by basically knowing up front which things are present or not. Now, there are other ways of handling that as well, but you're right. It doesn't give you a 100% answer, but it prevents you from doing an expensive query by filtering out many of them.
Got it. And that's a bloom filter. Why is it called a bloom filter? Do you know?
Yeah, that's a great question. I think because you do this multiple hashes, so you don't just do a single entry into a bucket. You normally bloom. This is my imagination, because it blooms out, and you normally do a couple different buckets by taking portions of it.
Okay, I have a really funny true answer. Well, that might be true, but
Oh,
also it's called it because it was created by Burton Howard Bloom. It's a true story in
dang it.
1970. But yeah, I mean, that's really interesting. Man, I can't believe that, that this someone in 1970 was thinking about this problem. That just blows my mind.
So this one was the first. This bloom filter was the first one I came across that was this. It's okay to be wrong, and in fact, it's just a tunable parameter. Um, this is sort of weird. Sometimes you get this if you do like DSP work or filtering or something, or you talk about floating point math. But for something that was like a data structure that's like meant to be somewhat broken, it's like intentional that it sometimes gets the wrong answer. It's by design. So Bloom filter and linear counting, at least in my mind, pretty similar. So moving on from linear counting to the next step, we're going to go to the tail end of HyperLogLog and talk about LogLog. So LogLog does something really interesting, that if we were talking about the Bloom filters, taking, Jason was talking about taking the J and hashing that, then taking the A and hashing that, right? So instead, if you just hashed Jason, the string Jason, you have a really good hash function. You could just use the first couple bits, the first however many bits you want, to determine, the bucket that you're going to go in, and then instead of storing just a single bit of, I had something in this bucket or not, you go to that bucket and you look at the rest of the hash. Say your hash was 32 bits and you had 5 buckets. So, did I pick bad numbers? 27 bits left. And those remaining 27 bits, you could either use the first or the last. It doesn't really matter. Count the number of sequential zeros. Now, this part was really, really weird to me. I didn't understand this. So take the number of, let's say, starting from the left to the right, count the number of zeros in a row that are in the next 27 bits. And then instead of storing 1 or 0 in the bucket, store the number of zeros. So if the first digit was a 1, you would put 0. If the first digit was a 0 and then a 1, you would put 1 because there's 1 0. But you could have 4 zeros in a row, and you would store that in the bucket. Now, if you were
So
like
it's
me,
the
that
number of leading zeros
yes,
in a row. Okay, got it.
the number of leading zeros in a row. And the clever probabilistic thing about this is that if you imagine that so your hash needs to be very good. So it needs to have a 50% chance of a 0 and a 50% chance of a 1 in
Mhm.
every bit position, or as close to that as you can, manage. Then what you would say is if you're going to look at a stream of unique IDs, you would expect that the length of sequential zeros that you would get is a function of the number of items you've looked at.
The length.
Okay, let me say it
Okay.
another way. If I said you're only going to play the game once, you're going to generate one hash and look at it, and I asked you to derive like what would you be the expected number of zeros you would see? It's much more likely to see 1 0 or 2 zeros in a row than to see 16 zeros in a row on the very first time.
Yeah, it's like a coin toss, right? It's like how
Yes,
many
it is.
times can you toss the coin and get all heads? Well, like as the number of tosses go up, that probability goes down.
Right. That's exactly the key to this. So if you look at a given bucket, and let's say you only kept one bucket, that's fine. You could just have one bucket and you keep track of this. Then at the end of seeing all of the items, you look at what the sort of like longest run of zeros you
Oh, now I
and you
get it.
say that I believe that I've seen 1 over 2 to that many number of zeros. That's the probability. So then I've seen 2 to that many number of zeros items
Right,
is my
right.
guess.
So yeah, let me see if I can rephrase it,
Yeah, go
like
for it.
paraphrase it, and see if I have it right. Um, So you flip a coin, there's a 50-50 chance you get heads. If you get tails, you're done, and that's a 0, you get 0 points. If you get heads, that's a point, and then you try again. You keep going until you keep accumulating points or you're out, right? And so, 50% of the time you'll get 0 points. 75% of the time you'll get 0 or 1 point. And so it just keeps going up like this hyperbolic ramp. And so, like, 99% of the time, you're going to get less than 10 points or something, right? And so, what that means is, what you're saying is, if you did get 10 points ever, then there's probably like 99% of the other trials there that you just didn't record because all you
Yes.
did was record the best score. It's kind of like it's like if you go to the arcade and the high score on Pac-Man, like, maybe they just rebooted, like, reflashed all the
Yes.
machines.
This is, yep.
Yeah, and the high score of Pac-Man, or actually, this happened to me where, I'm obviously not super Mr. Athletic or anything, but, I went to Chuck E. Cheese with my kids, and I always play the football game. Have you seen this at Chuck E. Cheese? You have to throw the football through
Yes.
the holes? Yeah. So I played the football game, and I won the high score of the day. And I felt like for a moment, like, wow, like I should have like played in the NFL or something. And then like 5 minutes later, like some guy behind me like got the high score of the day. And that's because they just reflashed the machines, right? So the high score, there wasn't a lot of samples, and so the high score was easy to beat. Conversely, if you go to like some other arcade, or if you go later on in the day, the high score will be super high and you can't even get to it. And so you're using the high score as an approximation for how many people have played the game.
Yes, that's the key insight. I guess we didn't talk about that part here, but you caught on to it, which is you want to record the maximum you've seen. So in this bucket, you record the maximum, and as you said, as the number of attempts goes up, and unlike your example where it's skill based, every one of these should be random. So
Right.
it's just like slot machine, and it's the whatever. Anyways, and so yeah, so the higher that number that you've recorded, you're going to make your guess go up. Now, you could get really lucky, unlucky, however you call it, and you see only a single number, and that number happens to have, 100 leading, we said 32 bits. It has 27 zeros in it. And so you think you've seen 2 to the 27 items, but you really only ever seen one. And so this is not good, right? This would make you have a very, a high chance of getting an error because of this one problem. And so the second thing, which I started off with there, is by having multiple buckets and then averaging them together. You take the first few bits, the first 5, and you choose your bucket. Then you use the last 27 and you do this thing I'm mentioning that we've talked about, recording the high score. And then by averaging all of the buckets together, if you've only seen one, sure, you're going to have this really large number in a single bucket, but all the other buckets are going to say 0. And so you're going to pull it back down to try to correct. And we're setting up for the second thing here in a minute, but this is called, I guess, like LogLog. I don't see a ton of evidence that this was really, rolled out or used, because there's some pretty easy ways to improve it here. We'll talk about in a second. But this idea of recording multiple max scores and then looking at the end and taking an average allows you to sort of approximate it in a very similar way. So the other thing we didn't mention with LogLog and LinearCounting in both cases is you kind of measure, well, in LinearCounting, you measure this amount, and LogLog, you have these coefficients as well, because you just sort of know on average you're likely to, kind of see these things. So you run some simulations and you kind of tune some constants to accommodate for kind of like edge effects, I guess you would sort of call it. So HyperLogLog improves on LogLog
Well,
by a
one thing
couple of
actually
things.
before you jump into HyperLogLog, I want to double click on something you said earlier, which is, I also went through this where, you know, I felt like even just hashing, I kind of felt like, how do you trust the hashing? And like, what happens if your data set is biased in a way where,
Yeah.
because maybe your data set all starts with HTTP colon, that now like your hash function isn't pure, and you have more collisions, or even like MAC addresses. I'm pretty sure MAC addresses are, well, actually, I don't have no idea, but I'm assuming that there's some kind of randomness there. There's no
The
way
first
all
few
the
are predetermined. It's by its hardware vendor sets the first few bytes.
Okay, got it. But then within a hardware vendor, at some point there's probably a collision, right? Or are there can't be like a global count of MAC addresses while the factory's like churning out tons of these.
Yeah, well, maybe there is. I think
Maybe
there's
there
not
is, I don't
supposed to
know.
be, but probably there is.
But um oh yeah. So like whenever I see hashes or all these things, I used to feel like, well, this isn't, kind of pure, it's not gonna work out. And how do you even know if you have a problem, right? And it turns out that yeah, at scale, you can't do anything very precisely. And so what you do instead is you try to measure, the bounds statistically of some issue, and then you're constantly correlating between other things. Like for example, maybe there's, a 1 out of 10,000 chance that you overestimate your unique visitors by 10x, right? And so 1 out of 10,000, that means, Google's been around for like 15 years or something. So there's probably like a 50-50 chance this has happened once, right? But what they're doing is they're constantly correlating that with other things. So, if the viewer count goes up by 10x, but the revenue doesn't move, well, then, that might be an error that day in the viewer count. And so, you're constantly trying to cross correlate between different data sets, different signals, and then also auto regress, correlate across time for a signal. And so it really just becomes about reducing the error and trying to reduce the bias and the variance of these signals. And so when you start thinking about it in those terms, then it becomes okay to kind of say, well, yeah, all of these errors are there. We're just going to measure them all in gross, and try and get that measurement to be as accurate as possible. And so, as they're making changes to these filters, they're comparing the correlation to, let's again just using our example, to revenue, and they're seeing, oh, you know the new value is much more correlated to revenue, which is what I would expect. As unique visitors go up, revenue goes up, and all of that. So you can actually measure all of these things and get better in an incremental way, even though it feels like a very helpless situation.
That's a great call out. I will say also, I think a lot of these techniques we're talking about time and a place. So like your financials, you wouldn't want to do this. You probably do a different sort of like way of
Yeah.
like the expensive query. But you can't maybe do that in real time. And then as you said, not only like comparing it with other metrics, but even just also running maybe like a second method that is less reliable or different parameters and checking that as well. So maybe it's less
Right.
accurate, but it gives you a coarser bound, right? And says, hey, at least I know that like if I get a 10x measurement, I need to throw it out. Like that's going to be wrong. So it can give me an order of magnitude kind of swag.
Yep. Makes sense.
Okay, so moving from LogLog to HyperLogLog, it's not a big jump. So the first one is for any buckets. So it's basically what happens with kind of very high numbers, like when you're starting to get very dense filled buckets, or very low numbers where you have a lot of empty buckets. So in the case of very low numbers, we have a lot of empty buckets. You may consider instead of taking the max counts and doing the average, where like I mentioned, you have 5 buckets, you happen to get one that was 27 zeros, you're going to way overestimate it. If you have a lot of empty buckets, instead, maybe just estimate the probability of having that many empty buckets. So, what is the chance that you saw, in the case your estimate there would be very high, like a million or something? So rather than estimating a million, what is the chance that you saw a million numbers and had 9 empty buckets? That is going to be very low. And so, you use that for sort of some corrections, as well
Hmm.
as very dense, just like in linear counting, we're talking about the more buckets sort of like have bigger numbers in them, the more chance that you're sort of seeing these collisions and you're sort of seeing a different behavior of the numbers. And so handle those as well. And a lot of that you just end up running by either computing the statistics or running simulations for sort of handling that rather than just, kind of a single formula that you run, you kind of have a sort of set of if you meet this condition or that condition or the other condition, apply a slightly different formula, but roughly the same thing. And that gives you HyperLogLog. So this HyperLogLog allows you to perform these analytics, get an approximate answer. I think the number that I was sort of seeing in the paper is like for the majority of cases with these corrections, you see like a 2% error. So if that is important, like in the case of maybe financials or something, you don't want to use it. But for the case of like counting how many visitors in a day, if you don't want to be lying to people, if it's like a court thing, so like you wouldn't run it. But if it's just, keeping track from day to day or hour to hour, as an example, you could run something like this and know that you're going to be generally close most of the time. And of course, a lot of those things are tunable.
No,
So the
very cool. It makes a ton of sense.
the final trick and the sort of like second thing that kind of like I don't know melted my mind a little, and there's a variety of these problems, and this one's going to get to Jason's example. So here we are at the very end, and you foreshadowed by talking about sending it to different computers and having each of the computers handle it. So let's imagine we chop up our logs and send all of our 1/10 of each of our logs to 10 computers, and each of the 10 computers does the thing we just described with HyperLogLog. What do you do at the end? Well, you can't sum the 10 results, right? Because if you sum the 10 results, it's the same. Now, if you divided them like Jason said, where I looked at their username and sent them to a computer based on their username, you could. But if I just chop the first 10% of the logs, the second 10%, and I sent each of those, some people will have two different computers will have seen the same user potentially. And so you don't want to just add up, hey, each of them, so 10 times, whatever number each of them, just kind of add them up. That won't work. That's not a good estimate. You need to dedupe them again. Well, the sort of mind blowing thing, or at least for me, is if you look at those buckets we talked about and everyone's running the same algorithm, you can just transmit the final counts of the buckets and just run the same max operation. So if you run the same max operation across all of the buckets and then do your final calculation, that actually works perfectly fine and is incredibly cheap. So if computer one says my first bucket has 8 zeros and computer two says, oh, my first bucket only has 5 zeros, then you final count for the first bucket is 8 zeros. And it's the same answer you would have gotten if you had sent all of the queries to only a single computer because of this, counting, keeping only the max. So this max for individual computers is, if you take the max across all computers, the same as if they had seen them because everything.
Oh, right.
This was not this like what? Then no, this ain't gonna work. It was my first inclination here, but it's this aggregating by max is the unlock because you're aggregating them all together by max. You can just run it at the end across all the computers, and you have it distributed as many ways as you want.
But wait, what was wrong with your idea of saying, well, just adding up all of the Oh, because there's duplicates across the
Yeah.
computers,
So
right?
imagine the entire log, 1 million entries is all
Oh,
username
yeah.
JSON. And I send each to 10 different computers. Each computer is going to estimate one, let's say. And then my
Yeah,
final result, say 10. The answer is actually only one.
right, right.
So again,
Oh,
for
right.
something like visits to Google, you may know on general how many times a given person visits in a day. Maybe you could do this via other means. But if you're using this for an analytical engine that doesn't know how likely repeats are or not, then this is a very difficult, thing to solve a priori with sort of like specialized knowledge.
Yeah, that makes sense. Yeah, that's totally mind-blowing. Another thing that this benefits from is that, each bit doubles the count. And so, the difference between 7 and 8 bits is so large that, if one says 5 bits and the other says 8 bits, by throwing away the 5-bit one, you're not throwing away that much because as I said, it's hyper logarithmic or whatever.
Yeah, its
So,
contribution is irrelevant.
yeah, right. Wow, that
So
is super cool.
I guess a couple of things slipped over. So one is that moving from LogLog to HyperLogLog, you also move from taking an average to taking a harmonic mean. So you take the harmonic mean of the buckets, which helps
Now, what
improve
does the
performance.
harmonic mean?
Harmonic mean is 1 over 2 to the n time, and then you sum those up for each bucket, and then you multiply by n at the end. And
Ah,
so
okay.
that's used for rates. So I try to look it up as well. It's like one step past my intuition about probability. So I'll keep noodling on that one and maybe have to get back to you. But
Okay.
they see improvement by moving from the sort of normal averaging that we would think about, just sum them all up and divide by the count, and instead moving to this harmonic mean instead. They see improvements there. And again, I mentioned these coefficient factors, and you would run simulations, and so they give estimates for what they see for these correction factors for high, low, offset, these kinds of things. So definitely read the paper. But I would also say that day to day life, are you going to implement this? Yeah, don't. I mean, maybe if you have, you could. But one, we mentioned a bunch of things along the way here: Bloom filters, probabilistic counting, knowing to go reach for one of these if you don't need an exact answer. The second thing is a lot of databases have already, like Redis and other things, have already implemented this under the hood for these kinds of operations. So you're likely already using it. And it's just for me one of those mental like aha moments where the chance that this specific solution is what I need to reach for is very low. But understanding a bit more about this space, I feel helps me sort of know when to go to the internet to search for something I don't know.
Yeah, so I mean, as far as using it, there must be some way in SQL to say like approximate count distinct.
Oh, interesting. I didn't look at so every sequel is different. So let's see. Postgres. This is
Yeah. I also
fascinating.
typed Postgres. Oh man, same wavelength.
All right.
Same wavelength.
I mean, it looks like there's a some add-ons you can kind of do to kind of distribute a distinct count with HyperLogLog on Postgres. I see a lot of articles about this. So uh, again,
Yeah,
feels
it
like you
looks
probably
like yeah, I agree. It looks like a plugin.
so
Oh yeah,
if this is
so you install this plugin in Postgres and then you do HLL underscore cardinality. And so but I remember I think this is Sawzall. I remember there was I do remember in my life typing select approx count distinct. Like that for some reason is like just radiating through my mind. So there's definitely some system that has it built in.
yeah, I mean I think they're like probably in Hadoop for this sort of very distributed processing of things. So unlike when you have it on a single computer, but you have it across multiple computers doing large analytics, column data. So I would imagine like Apache Arrow or something. This is
Yeah, exactly.
very similar.
PySpark,
Where was that?
Spark and PySpark have a prox count distinct. That's where I've done it. Um, that's amazing. I had no idea that that was doing that under the hood. That's like totally mind blowing.
I don't know. So maybe write in if you like this detailed singular algorithm exploration. I mean, I guess we touched on a bunch of stuff, so maybe it's not that dissimilar as I thought it might be in my head. But Jason had to play along here, so he's at least acting like he walked away understanding this a bit more.
No,
So
this is amazing. I definitely learned a ton. No, we should definitely do more of this. Yeah, please write in, let us know plus or minus. But I actually learned a ton. This is really satisfying. Another thing is, you know, when people get a CS degree and they learn about quicksort and merge sort and all of these things, they might say to themselves, well, like, okay, like we figured out how to sort, we're done. Like, why even teach this to me? Like, why are you teaching me a one-liner in any modern programming language? And what you've kind of shown folks here today is that like this doesn't end, sometimes you need probabilistic things. Sometimes you're working in very limited environments. There's all sorts of different types of counts and things you do. And so computer science, like you can do it all day as your job. And like literally the science part of computer science. And there's a lot of fun stuff.
well, I think that brings us to the end of another episode, 169. Wow.
Yeah, pretty wild. Thanks everyone for sticking around. Yeah, we should definitely uh, do something for our long-term patrons. I'm gonna do some digging on my end, figure out if I can get that like number of months subscribed and all of that. But thank you so much for supporting us all of these years. You've been able to just continue to grow the community. I'm considering using some of the community money to buy Twitter ads. It does feel like our Twitter presence is growing pretty good organically. And so, at the end of the day, we try to get as many folks interested in programming computer science as possible. And we couldn't do that without all of your help. And so we do put, every dollar that you donate towards trying to accomplish that goal.
Yes, thank you to all the people who have stuck with us for I always forget how long it's been, but for a very long time, including Jason. Thank you, Jason, for all your hard work.
Thank you. Someone commented asking, we did two shows on Bitcoin. One was episode 7 or something, and another show a few years later, and they were asking if we bought Bitcoin at those times. And I'm sad to say the answer is no. We did not buy Bitcoin at, I think they said 50 cents or $500. We didn't buy Bitcoin at either of those prices.
I didn't, but after that show, I did install. I got some Bitcoin out of a faucet, but unfortunately, it was like 0.01 Bitcoin or something. So that was the only Bitcoin I had left from that.
Yeah. So yeah, we answered the that's definitely the most asked question, I think. I think about once a month we get asked that. Someone asked it on Discord last week, but I do get a lot of email. Hey, did you guys buy a bunch of Bitcoin? We didn't do that.
Don't remind me, man. Don't remind me.
Yeah. That wound has been sufficiently salted. But thank you so much, folks. It's awesome that we have such outpouring of support. A bunch of folks asking for different languages. We will definitely get to that. But I also want us to cover algorithms. This was a really exciting kind of new branch for the podcast. And so thanks, Patrick, for doing the background homework on this.
All right. Until
All
next
right,
time.
catch everyone later.
Music by Eric Barndollar.
Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.